Today we're going to solve a system of equations using the Gaussian elimination method. We're going to begin by putting the coefficients of our two equations in matrix form. 3, negative 1, 1, 2. The values after the equal sign I'm going to put also in the matrix. It's called an augmented matrix when I put the dotted lines like that. My goal is to get this original 2 by 2 matrix here into the identity matrix, which is known as 1, 0, 0, 1, by doing a series of steps. And I'm only allowed 3 possible kinds of steps to do to this matrix. I can multiply a row by any number I want. I can multiply a row and then add that new number to an existing row and replace the elements. And the third thing I can do is I can simply switch rows if I want to, or flip them. So I already noticed that in the second row I have a 1 where I'd like it to be up here in that first one. So the first thing I think I'd like to do is simply just flip the 2 rows that I have. So the 1, 2, 10 goes on the top, 3, negative 1, positive 2 on the bottom. The next thing I'd like to do is see if I can possibly make this 3 into a 0. So if I multiply this number by negative 3 and add it to that row, it will make it a 0. So I'm not going to do anything to change the top row, so I can write those numbers back in again. If I multiply 3 times 1 is 3, negative 3 times 1 is negative 3, add it to that 3 down there and I get 0. Multiply negative 3 times 2, I get negative 6, add it here and I get negative 7. Negative 3 times 10 is negative 30, add it here and you get negative 28. The next thing I'd like to do is see if I can make this negative 7 into a 1. So that's actually a pretty easy step. Again, I'm not doing anything to the top row. I'm going to multiply the bottom row by negative 1/7. I have 1 there, and negative 1/7 times 28 is positive 4. So you can see I'm on my way to getting what I'm hoping for. Now my bottom row is the way I want it to look, but my top row still has this 2 here, and I would like it to say 0. So if I multiply the bottom row by negative 2 and add it to the top row, negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times positive 4 is negative 8, add it to the 10, and I get 2. And notice that I now have what's known as the identity matrix. The matrix that I have here on this side actually becomes my solution matrix. The top number is the first variable that I was trying to solve for, which was x of 1. The bottom number is my x of 2 value. So therefore x of 1 equals positive 2 and x of 2 equals positive 4. I can write that. Okay, there we go. No? There. Let's just check our solutions, make sure that they're correct. So if I go up to the first equation, I have 3 times my x of 1 is 2, minus my x of 2 value, which is 4, should equal 2. 6 minus 4 does equal 2, so check. The second one is x of 1 is 2. 2 times x of 2 is going to give me 8, and that's supposed to give me 10, and I see that it does give me 10, so it checks out. So the solution to the system of equations is 2, 4.